A pretext is a purpose or a motive alleged, or an appearance assumed, in order to cloak the real intention or state of affairs.
Initial access. OMI is trying to get into your network.
Listen, this is your manager, and I'm trying to send off an email. I got this document. Need you to confirm a few details. So go ahead and log in and tell me what you think. I need this now, so to make this convenient, here is the link. I'm a threat actor, fishing mark for email is urgent to distract you with it. So how fast you clicked it when you submitted the form with your password in it. You probably couldn't tell there was an actual difference in the URL. The domains look alike though, and to you will look fine though, but mine had typos and make it look like yours. See, I was in the mood today to make your account a communal space, but then you activated your trap card, and I saw you had 2FA, but I just shrugged, I'ma shake it off. Got on kid gloves, I'ma take them off. Got your phone number, I'ma make a call. I'ma break this wall, it just makes me lol. I'm moving quick, I'm on a mission. Yeah, I heard your network is lit. I'm trying to get in. Yeah, I'm trying to get me a hit. When I go fishing. Yeah, you probably think it's legit. I got you clicking. Yeah. Hello. Hi. I'm calling you from the IT department. We have been under attack by some hackers, and we think that your account might be a target.
Oh no! How do I fix this?
No need to worry, I wrote up a ticket. You'll get a notification from your authenticator app, so please pass me them digits.
1 sec.
Okay.
Yeah. The code is 112345.
Thank you. You fell for the lie, so I hung up the phone without saying goodbye. Cutting it short like a crew cut. Probably think it won't happen to you, but it happened to Uber. They say you win some, you lose some. Boys got a smooth touch, hacking you too, bruh. You know how I be creeping, and I'm logging in your VPN. It probably looks anomalous. Some logs if you be keeping them, and probably unaware about the shares that have been peeping. And the reason I'll be seeking them, I'm looking for an easy win. You probably thought it was a magic trick, and you're mad you clicked. I'ma stack my chips and bet that a DA password is sitting in an admin script. I'm moving quick, I'm on a mission. Yeah, I heard your network is lit. I'm trying to get in. Yeah, I'm trying to get me a hit. When I go fishing. Yeah, you probably think it's legit. I got you clicking. I'm moving quick, I'm on a mission. Yeah, I heard your network is lit. I'm trying to get in. Yeah, I'm trying to get me a hit. When I go fishing. Yeah, you probably think it's legit. I got you clicking.
Hello everyone. Hello and welcome to today's session of the Azure Cloud Security Meetup group. So, as usual, Ibrahima, the same question that we get anytime we play this music. we have people asking, what's the music that's playing? So I'll dig up the link so I can see like the questions. I'll dig up the link and I'll put the link in the chat window. So the music is clicking by OMI, so it does like nice netcore music. So I recommend everyone to check it out. So the one that we're playing is called Clicking. So Ibrahima, how are you doing today? Everything all good? Oh, I think your mic is muted. So I think we can't hear you. I think your mic is muted. Oh, so still the same thing. I can't hear you. So I'm not sure why. But okay, anyways, so while Ibrahima is having a look to see what's going on with his microphone. So again, thanks very much for joining us. What I'll do is I'll put the link of the community group in the chat window. So if you're yet to join the community group, ensure you sign up. So that's where you'll be notified of other events or other sessions that we are putting together. So Ibrahima, are you back now? Everything all good? I think I can hear your mouse clicking. So, can hear you again. It's all right. Yeah, it's okay. So I'll just stand in. Oh, I can hear you now. Awesome.
Okay.
Yeah. Okay. Awesome.
Hello everyone.
Yeah.
And how are you doing, David?
Yeah, busy. So I'm currently actually at the Microsoft MVP Summit in Seattle. So, and
Awesome.
If I show like behind me, you can see that there's lots of like IT engineers, developers, security people, just right behind
Yeah.
me. So it's been we just started today. So Scott Guthrie is currently giving his keynote, and then after that we get into the deep dive sessions. So I'm looking forward to that. I think it's going to be awesome. So we do have someone very special today to the community. So Karl has been doing Azure pen testing before anyone even thought Azure pen testing was what's doing. So Karl is one of those geniuses in this area. He spent a lot of time. He's put in a lot of effort. He's come up with like amazing tools. So tools like Microburst, which I'll put the link in the chat window again. So the tool was written by Karl. So those were like my own initial tools in terms of Azure pen testing. The Microburst tool written by Karl. Karl has spoken for us a few times in the community before. So I believe that Karl has done like about 2 or 3 sessions with us. Karl and myself actually wrote a book together on Azure pen testing called Pen Testing Azure for Ethical Hackers. So, and it was a wonderful experience through and through. I had the privilege of meeting Karl and his lovely family when they visited London also. So, without any further ado, I think we can bring Karl online. Hello, Karl. How are you doing today?
Hey everybody, good to see everybody again, and it's nice that we're finally in the same time zone again. Kind of a rare occurrence for David himself.
Yeah, absolutely. And one of the things that I also forgot to mention, Ibrahima, is that Karl is one of those people in the world that no matter what, if you see like Karl from 10 years ago and Karl now, it looks as young as it looked like 10 years ago. So he has one of those rare genes where, where he's always looking young no matter what. Anyways, so Karl, like, you've been causing trouble for Microsoft again, as always. You went and dug up some stuff on Azure Functions, and you're going to be sharing some of those with us today. So what we'll do is we just hand over to you, let you introduce yourself, let you introduce the session, and then we'll let you get on with it. So if anyone has any questions for Karl, please put it in the chat window. Also make sure that you invite other people, and then we'll let Karl get on with it. Thanks for this.
Sounds good. Well, thanks for having me on again. It's really nice to be back on this meetup group here. I will get everything into presentation mode here. Hopefully everything shows up all right. So today we're going to be talking about a recent vulnerability disclosure that we had with Azure Function Apps. We'll talk about what Azure Function Apps are, the APIs that led up to the vulnerability, and the full exploitation of the vulnerability. What's nice about speaking to this group is I don't feel like I'm going to have to spend a lot of time explaining what function apps are, because I think most of the folks that'll be joining on this call here have a relatively good idea what they are. So we can actually really focus on the deep dive technical details without having to spend too much time, kind of the ramp up here. So David gave a great introduction here for me. I don't have to touch on too many points here because David covered that for me. But a little bit of background on myself. I'm a VP of research at NetSpy. I've been with the company for a little over 11 and a half years now, which is kind of unheard of in the security industry. Decade plus of being at a single security company is kind of unheard of. But really enjoy being at NetSpy. I get to do really cool things. More recently, I've switched off of being the lead of the cloud pen testing team over to more of a research and product service line development kind of role. So just digging into all sorts of interesting things that we can do at the company and getting to build cool stuff. So as part of that, still keeping on with my cloud researching. We'll be talking about some of the research that I did middle of the year last year, but we finally got clearance to disclose it earlier this year. And continuing on with tool development, I still occasionally push updates for Microburst, which David mentioned here. It's a tool that I use during a lot of my cloud research and helps support a lot of just pen testing activities within Azure. Outside of being a co-author with David here, I also do Azure Cloud Pen Testing training through the Dark Side Ops training that we do here at NetSpy. So I'm a trainer there, and then in my spare time, I like to fly airplanes. So I've got my private pilot's license. So not only do I spend time in the clouds, I'm literally in the clouds as a pilot. So there's my dad joke for the day. And yeah, you can find me on Twitter at @kfosaaen. Also somewhat active on Mastodon, but not a ton. So question in the chat here about the time to respond to fixing bugs in Azure. We'll talk about the whole timelines for this one. This one was a bit of an extended tenure for getting a fix out, and we'll talk about why that is when we get to the actual timeline disclosure here. But this was kind of an interesting one to go through. Definitely took a while to get through, but I'd say it's on par with a couple other issues that we've run through Microsoft. So, like I said, today we're going to be talking about a vulnerability that we identified within Function Apps. Just a real quick rundown for everybody so that everybody knows kind of the same terminology and what we're working with from an infrastructure perspective. But what are Function Apps? So Function Apps are a subset of the app services resources within Azure. App services being application hosting, Function Apps really being more of the API hosting. You have the resource itself, which is the Function App. The top screenshot that we have here, we have the NetSpy Function App. Underneath that, we have HTTP trigger 1, which is a specific function. So in this case, we'd have netspy.azurewebsites.net /HTTP trigger 1. That's the endpoint or the function that's going to be called for the NetSpy function app. You can have multiple functions within a single function app, and all of those are controlled with keys in terms of gaining access. So at the function app level, you have the master and default keys. The master key actually allows you to fully control the function app. There's a couple of great walkthroughs that are out there currently about gaining access to master level keys and what you can do with that. The core thing that I really care about is being able to overwrite function app code and be able to execute code in those containers. The containers being serverless containers, either Windows or Linux. We're going to talk about both of the different options here for container hosting as we go through the vulnerability. Seen in the chat here, is it a bit blurry for everyone else or just me? If you want, I will increase the size here on the slides. Just a moment.
Yeah, I was going to say that. So it was.
Hopefully that helped.
Yeah. So let me have a quick look. So a little bit next.
I can shrink myself down here as well. So, all right, there we go. Hopefully that helps.
Thanks.
So let's see here. Talking about serverless containers, all of that good stuff. Windows and Linux, we'll talk about the two different containers and why the vulnerability impacted them differently. But the key things that we really care about are kind of how authentication works. You can have anonymous functions along with individual function level keys. So keys that you can just use for that individual function. And kind of last things here, function apps do support managed identities. So in Azure, we have a concept of managed identities where you can, as a resource, act as an identity within Azure Active Directory. So in our case, a function app could act as its managed identity and then access resources in Azure Active Directory or Azure Resource Manager, anything like that, depending on what roles are applied to that managed identity. And you can do all of the editing of these functions within the portal itself. I find this really convenient. I'm a little bit lazy when it comes to development. So it's nice for me to just pop into the browser, put the code I want to run into the function, and just do everything in the browser instead of pushing everything through Visual Studio or anything like that. Just rather edit everything in the portal and be good there. So really convenient. But as part of that, that leads to the vulnerability that we're going to talk about today. So in order to access those files in the editor in the portal itself, the Azure portal utilizes something called the VFSI or VFS API. I believe it stands for Virtual File System, based off some documentation I've seen that kind of tracks, but Virtual File System API, it allows you to access the virtual file system of the containers hosting the function app. This is where the remediation has kind of taken place for the issue. So reader roles no longer have access to read the application files or go through kind of the code test menu. If anybody's played around with the reader role and function apps more recently, you'll notice that you don't have access to this anymore. That was Microsoft's fix for this. We'll talk about why I don't think that's totally the correct fix, but that's for later. This is still available for anybody that has contributor on the function app. So developing function apps within the portal, still totally doable. At the function app level, we can see the app files. And here you're going to see kind of the requirements, the profile, the settings for the overall function app itself. This is available directly in the function app menu in the portal. And if we go into the individual functions, in this case, timer trigger 1, and go into code test, we see a very similar looking menu here that shows all of these supporting files for the function app function. With both of these, they utilize the VFS API to list out the files that are available and then retrieve the files. And then if you're editing any of it, you can then save it through here as well. Like I said, this is still available through both app files and code test for contributor and above with the roles within Azure. And this is kind of the source of the vulnerability. As I was playing around with some function apps and trying to assess the security of some files that were associated with the function that was being called. I was noticing that some of the files weren't totally visible or available. They were put within a folder within the function, and I couldn't see them in the dropdown here. I could just see the main couple of dropdowns here in the code test. I thought that was a little bit weird. So I put all of my traffic through a tool called Burp Suite. It's a great web proxying tool. If you've never used it before, highly recommend for any web application testing. And seeing in the chat here is still a little bit blurry. I guess
I
everything
think that for what you currently have now, I think the graphics looks nice. I think it's
Looks
when
good.
the graphics are smaller that then becomes a bit blurry. But what you currently have now looks good.
Got it.
Yeah.
Okay, thank you.
you.
So using Burp Suite to proxy all of the traffic here, notice some of these URLs coming back with the VFS endpoint. So in our case, we've got a management URL here and going all the way into the function apps and VFS // and relative path equals 0. So what I was seeing on my side was relative path equals 1, which really just showed the couple of files that we were looking at initially here, function.json, readme, run.ps1, those kind of things. And if I set that relative path to 0, I was actually able to see the container files, or the files that are on the specific container hosting that function app itself. So, this is a really basic web application vulnerability at its core. I found a URL that looked very interesting. Okay, virtual file system, it's traversing paths. We just changed one parameter from a 1 to a 0, and now we have unrestricted access. Extremely simple. This is just parameter manipulation to do a directory traversal. Very, very simple. So once we identified that URL and we're able to start poking around with the file systems, all of that, I started with a Windows container because that was the function app that I was playing around with in this specific environment. And I didn't really know what I had gotten into. So with poking around the Windows container itself, we were able to gain access to the data protection keys. So we can see in the URL, and I know it's a little bit small text here, but if we go to the root of the container, ASP.NET folder and data protection keys folder, we can get access to XML files that contain the data protection keys, which are used by .NET to encrypt data within the applications itself. Now, if you had access to encrypted data, you could potentially, as a reader, get access to these keys to then decrypt anything. It wasn't hugely impactful right up front. This was actually the first iteration of reporting to this to Microsoft. I didn't actually get into the Linux containers, and what we'll show is much more impactful in just a minute here, until about a month later, where I was actually trying to show the same issue to somebody else and went into a Linux function app instead and realized, oh, hey, there's actually a lot more to poke around with. So I should probably have been a little bit better with my variation testing here before I submitted to MSRC, but I was excited to get access to these data protection keys and sent them the report. So initially Microsoft came back and said, hey, for the Windows containers, getting access to these keys, we consider reader to be a relatively privileged role. And by gaining access to these keys, it's really just an information disclosure. There's no elevation of privilege here. It wasn't that they wrote it off, but it was just kind of a, we'll fix this in a little bit. This isn't a huge immediate priority. So kind of in the meantime there, while I was waiting for a response from MSRC, this would have been early August of last year that we initially reported. I was poking around with the APIs still to show somebody else here at NetSpy what we'd found. I thought, this is kind of cool. Maybe we can take this further, and ended up poking around with a Linux container instead, which was very different from the Windows container, not just from an operating system perspective, but from an exposure perspective as well. So with the Linux containers, and by modifying that relative path to set it to 0, we had access to the root file system for the container, and that allowed us access to the proc folder. So if you're not familiar with the proc folder, that contains individual process IDs or PIDs for everything that's running within the container there. And underneath each of those PIDs is a /environ directory or file technically that exposes environmental variables. So we scripted this out here in PowerShell, just do a bunch of invoke web requests with a bearer token to hit every number that came back when we hit the proc directory from this API. And for each of the process IDs that we identified, try and hit the /environ or the environmental variables URL and return back any environmental variables that are there. So you can see some of the code here. I would just output everything to a temp file and then get content on that to get the actual contents of the environmental variables. And what we found is that the process that was handling the function app itself as the container got spun up was actually containing sensitive information in the environmental variables. So from our perspective, we were going from a reader that had access to these APIs to then being able to traverse directories into the proc directory, then getting access to environmental variables. Okay, we're making some steps here. In those environmental variables, we found a container encryption key, as well as a start context SAS URI. So this is an Azure-centric group here. You're probably familiar with SAS tokens, but storage account SAS tokens being used to give access to specific files within a storage account. So in this case, we have a blob storage account here that had a configuration file, which we'll take a look at in a second here. In that SAS URI, that with the encryption key, we're being passed to the container when it spins up. That gets decrypted by the container itself, and that tells the container, hey, here's how we're going to operate, here's how everything works, here's how we need to configure that container. So within that encrypted configuration file, the very start of it here, we have the encrypted context and we have the initialization vector. Then we have the encrypted blob after that. And putting those two things together with CyberChef here, we were able to decrypt all of the contents of that configuration file. So this is super interesting from our perspective, because now we're seeing everything that is used to spin up the container itself. In that encrypted configuration, we were able to find storage account connection strings, which there was recently a blog post by Orca that was talking about getting access to the storage accounts for function apps and being able to take over the function apps with that. There's some really cool research being done in that area. I won't get too far into that, but that storage account connection string, you can then get access to the storage account. Again, we're going from reader all the way up through these APIs to then getting access to this encrypted, now decrypted information, and being able to get access to that storage account. Along with that, we can get access to source code zip files. We've got a couple of different URLs that were included within that to get access to the source code for all the function apps. And then the really impactful thing here, getting access to the secrets. So as we decrypt all of that encrypted content here, we get access to the individual function secrets, as well as the master secret for the function app itself. Now, this is really impactful because we can go from a reader all the way up to getting access to the source code for the function apps itself, and we can overwrite it at that point. So it's really just as simple as a put request with that master key, and we can overwrite the function app code. At that point, we can get access to the managed identities. If those have access to key vaults, storage accounts, any other functions within Azure, Azure Active Directory, we can now generate tokens for ourselves. Pretty simply, depending on what your programming language is, you make a call out to the IMDS or metadata service and get your token back, and then use that token separately. In terms of function apps, you could potentially just have that output with the function and you just call the function, it returns back the token for you, or you could have it make some kind of reverse channel to a server that you control, and it posts back the token at that point, which you can use. So super impactful at that point, getting full code execution within the function app containers. Now, granted, this is just for the Linux containers. We didn't find any similar escalations for the Windows ones, but it's definitely a step up from what we initially disclosed. The initial disclosure was, hey, got access to these .NET keys. You might be able to decrypt something with that, to going from reader all the way up through code execution on the Linux containers themselves. So pretty impactful there. Last little note that I'll put on for the Linux containers here, if you have Azure Active Directory authentication included in the function app, there was the Wiz vulnerability, the Bing Bang. So people might be a little bit more familiar with kind of how Azure Active Directory integrates with app services now. But if you're using that similar kind of integration where an app registration is used for Azure Active Directory authentication, those credentials are actually stored in clear text in that configuration. So we can pull those out as well and get access to the app registration that helps manage the authentication for the application there as well. So lots of stuff that comes out of this configuration file. Once we decrypted that and got everything back, it was, okay, wow, this is a very impactful thing. Like, this is pretty cool. So we amended everything to send back out to Microsoft. We did the initial disclosure way back in August or early August of 2022. It took several months to get an initial fix out. I think Microsoft was going back and forth about what actual fixes they wanted to roll out and how they wanted to secure everything. But the initial fix went out in January. A few days after that, it sounded like MSRC and Microsoft were getting some complaints from clients about the implementation of the fix and some problems that were being caused there. So we had to wait another 2.5 months almost at that point to get the final fix rollout in early March. So there was a question at the beginning of all of this, with Microsoft being a little bit slow to acknowledge and fix bugs in Azure. This is the second vulnerability that I've had that's taken greater than, we'll say, 6 months or more to remediate. There was a log analytics contributor role vulnerability that allowed you to basically take over an automation account run as account, because that full automation account star permissions in the log analytics contributor. Anyways, reported that end of 2020, and I think by August of 21, something like that, if my timing lines up there. That's when that finally got remediated. So that took a solid 9-ish months roughly. And this took roughly 9 months, 8-9 months to get fully remediated. So sometimes with these slightly less impactful things, they just take a little while to get through. There wasn't any indication that this was being immediately exploited either. So to MSRC's credit, it wasn't an immediate threat. We weren't publishing anything until after everything was remediated anyways. So there was less of a push on that as well. So that remediation is now the reader role within a function app does not have access to any of the files. Those APIs are now restricted for anybody with the reader role. If you do have different roles, you can still gain access to those APIs, where I think that this isn't kind of the fully correct fix. I think that they should still be restricting that parameter for the directory traversals so that you can't get full access to, say the proc file system and get access to all of those potentially sensitive files that are sitting there in the container. That being said, if you already have contributor on the function app, you already have control over all of this anyways. So it's kind of a moot point, but restricting it for the reader role does technically fix all of that. Yeah, so like I said, it took a little while to get through all of this. We had a couple of different kind of starts with the reports. We submitted the initial one, submitted the secondary report. So there was a little bit of confusion with MSRC there, but eventually we got through all of it and everything got remediated and we were able to disclose it. So any questions around that?
So I'm looking at that, so I can't see any questions in the chat window yet about that. So I'll keep an eye on the chat window.
All right.
Yeah, thanks.
You did? How was it?
And I'll switch my camera back here. All right. Yeah, that's all I have for you today. Ran through that one a little bit faster than I expected, but wanted to give everybody a quick overview of all of that. If you have more questions about it, feel free to ask them here, or feel free to check out the NetSpy blog. We've got the full write-up there with kind of command execution examples, all of that kind of stuff. Just kind of the full write-up over on the NetSpy blog. I do see in here in the chat, no questions, but more curious about the pilot license. So my wife actually has had her pilot's license for, we'll say, quite a while. And she actually got me interested in it after she had taken me up in a plane to fly around in Oregon here. So I was just something that I kind of caught the bug and spent a couple of years. It took me a while to get my license, just being busy with life and work and everything else. But yeah, now when we find free time, we like to go out and go fly.
And I guess Microsoft keeping you busy also with all the new announcements and services with vulnerability.
Oh yeah, every time we get an announcement about, oh, there's new services out here, I
Yeah.
can spin something up and start playing around with it and try it out.
Yeah, it's a very like to that point, it's a very very interesting one because one of the things that I spent time looking at in the past was the timeline of some of these vulnerabilities in terms of when did the service initially come online in Azure, or when did this feature, or when was this feature announced in Azure for like a vulnerability was discovered, maybe for that service or for that vulnerability. And it's such an interesting one that you see, like how quickly, like how some of these are like transition from, oh, here's a new feature, it's made a default part of the service, and then it's found to be vulnerable. So it's like in this particular case, this is just a default capability in the service also that initially affected everyone that's using that service and stuff.
And what I thought was kind of, I don't know if it was odd or what, but to me, this is such a basic web application vulnerability and something that lasted and kind of persisted for so long. I was just kind of surprised that it worked. As somebody who's done web app and network pen testing now for quite a while, I was just really surprised that something so simple as changing a parameter would allow for this kind of directory traversal and then kind of full access through the proc file system there. That was kind of surprising for me that it would make it this far, as long as Azure Functions has been around for quite a while.
Yeah. So let me ask this other question also. So from your perspective, in terms of like all the research that you've done and all this recent announcement, with Big Bang vulnerability disclosure that you mentioned also recently, in your opinion, what is it that needs to happen with cloud providers like Microsoft? What do you think they need to do to ensure that we get like less of these types of issues that you're having, like these services that even like governments and massive financial organizations are depending on these services in the back end to run very critical applications. So what would you what do you recommend in terms of what they need to do from a cloud provider perspective?
Well, so I think there's kind of three different perspectives. There's the Azure platform security. There's Microsoft kind of platform security, as you were talking about the Bing Bang, the Wiz vulnerability that was just out recently, and then kind of individual organization security. You've got that shared responsibility model that's out there for cloud providers are responsible for up to a certain point of security. And then the individuals that are hosting their workload services, whatever, on cloud providers, they have their own responsibilities to secure their own configurations. And that only goes to a certain point. Microsoft's responsibility only goes up to a certain point. As long as both sides are kind of committing to having secure environments, then everybody should be good. But when you start identifying vulnerabilities in the platform itself, that kind of lessens a little bit of the trust of people who are hosting things up in the cloud, and that causes some friction and potential problems there. I think as long as Microsoft keeps making it a priority, I know that they put occasional challenges out through MSRC to look for specific vulnerabilities that they're concerned about somebody exploiting. Cross-tenant, cross-site scripting, some SSRF. Those have all been specific challenges in the past through MSRC to really try and find some of those vulnerabilities. I think those are all good. I think they're all kind of steps in the right direction. I know Microsoft's done a really good job of doing variation testing. So I mentioned that between Windows and Linux containers, Microsoft's definitely chased down a lot of those different variations for those kind of issues. When we found the CRED manifest issue a couple years ago now, that actually was affecting multiple other services, not just automation accounts. We initially reported with automation accounts. They came back with 2 other services that they identified of, oh, hey, these are actually storing information in that same spot in the manifest as well. We'll take care of those. So I think they've taken a lot of steps to kind of move in the right direction there to fix those things. With the Bing Bang thing, I think that's just moving quickly and building things, and oops, somebody made a mistake when they were building something quickly, and Wiz just got kind of lucky finding that.
Yeah, it's a very interesting one. Like more recently, like when I give like architectural guidance to people, and say, talk about like zero trust architecture. Like the trust architecture needs to extend to your cloud provider also. So not necessarily because you don't because you have to trust some aspect of their service that it works, it's going to be available. However, from a security perspective, you're aware that at the end of the day, you have developers that are writing code. And in some cases now, with all the co-pilot, autopilot, AI writing some of the code, stuff could happen, right? Things could get past, like, a lot of like the automation and all the advancements that we have. Ibrahim, I think that there's a question that you want to read out to Karl that you have there.
I think it's clear for me, and the question just you mentioned was at least also interesting. It was also a question that I would ask, but it's now clear for me. So thanks.
No problem there. I think there's someone asked, are you able to share the slides?
Yeah.
The post to the blog post. I think that the post to the blog post is already been shared in the chat window.
Yes, I already shared the blog post.
Okay. Yeah, I would say we can share the slides. I've already got kind of a version of this slide deck already recorded on the blog post itself. So all of the good information's up in the blog post. So I'd recommend checking that out.
Nice. Okay. And then probably final question. So like, where else should we expect to see you? Speaking at an event, like an upcoming event. I know there's like RSA DEFCON, and you're very much involved in DEFCON and the Cloud Village and everything that's been going on. Should we expect to hear you speak at any of those events later?
So nothing booked yet, but I am planning on being at DEFCON. I'll be around for Black Hat. I've got submissions into both, so fingers crossed something gets accepted. But yeah, I'm at DEF CON almost every year. So I volunteer with the now called merch department, but we sell t-shirts and that kind of stuff. So if you buy a DEF CON t-shirt, chances are I had some kind of interaction with you in the past, potentially selling DEF CON t-shirts. So definitely find me there, but currently no speaking engagements booked at the moment.
Awesome. Thanks very much again, Karl. Much appreciated. Again, I highly recommend people to go through like the video again. Lots of information that Karl shared there. At least even if for me, I think it's giving a greater insight into like the inner workings of like the Azure Function Apps, for things that you normally not look into if you're just using the service from just a developer perspective, and even look that deep into what's going on in the inner workings, and it's giving much more greater details. So thank you very much for that.
Yeah, thanks for having me back on. It's great to see both of you, and really appreciate being on today.
Yeah, thanks. Ibrahim, a final word from you. Everything all calm in Paris now. You've calmed everyone down, right?
No, just thanks both of you. Thanks to ones that join us today, and have a nice end of the day.
Yeah, thanks very much. See you next time, everyone. Bye for now.
Thank you.
Thank you. Bye.
Bye.